suppose we have events C and D, where the probability of C is 0.5, the probability of D complement is 0.3, and the probability of C union D, so either C or D or both events happening, is 0.9. Determine the probability of D given C, and determine the probability of C given D. So we've got two conditional probabilities to work with, okay, that we need to calculate. So we should figure out the actual expressions for calculating them. Okay. And the order here does matter. So D given C, we're going to divide by the probability of C. Okay, whereas for C given D, so assuming that D has occurred, we divide by D. Okay, because we restrict to D as our new sample space. For both of them, however, the top is just the intersection, probability of the intersection, that is. Okay. Now we're given a probability of C in the question. It's 0.5. D complement is another probability we're given. Okay. But if the probability of D complement is 0.3, 1 minus that should be the probability of D. So we pretty quickly can determine the probability that D will occur is 0.7. Okay. So that's the denominators that we need, but we also need C intersect D. So what can we do? Well, we know the probability of C union D can be expressed as the probability of C, which we know, the probability of D, which we now worked out, minus this probability that we're interested in. And we can rearrange this expression by subtracting C union D from both sides and adding the probability of C intersect D to both sides. And we rearrange this, and it allows us to solve for the numerators that we need. Okay? So C, 0.5, D, 0.7, minus the probability of the union, which was 0.9. 1.2 minus 0.9, 0.3. Okay, so we'll have 0.3 on the top for both of them, 0.5 on the bottom for one, and 0.7 on the bottom for the other. But it does matter which one. Okay, it really does matter the order. That's one of the things I think people tend to screw up most with conditional probability. Okay. So 0.3, probability of the intersection on top. Always divide by the probability of the given thing, the second thing. This is D, given that C has occurred. The probability of C was 0.5. We could simplify this to 3/5. Okay. Divide by the probability of D, because D is the event we're assuming has occurred or is guaranteed to occur. Okay. And we can simplify that to 3/7. And those are our two answers.